and welcome back here on the Ludwig Fusel channel to another video in my C++ tutorial series. In the last video we have improved our INI parser by basically just modifying one function, adding a few other functions in, replacing some if and else with switches, and boom, the code was more readable and more simpler to write for ourselves. And that was a good thing, and today we're going to continue on refactoring this code and really from now on we're going to add a few functionalities of course as well, so that the code gets a bit more flexible, but like the big meat of the code, the state machine itself, this is not going to change in the next videos. However, we're going to modify this and bring in new concepts of the C language to basically make this more versatile, and at the same point teach you how to do things properly, if you can ever do things properly, because like properly is always something that people have in mind, and there are many ways to get something done, and this is just my opinion on what is good. So that's kind of like the idea, but that's not the point. So I'm gonna try to teach the best practice, and best practice in my case, I've done this quite a long time, this programming stuff, and things that worked for me. So today we're gonna talk about separating so the source code that we have into multiple files. Currently, if you take a look at all projects that we ever had, they always just contained out of one C file. Like the simple C was one single C file, the pointers was a single C file, the memory utils was a single C file, and the INI parser was a single source file. And what we want to do today is we want to explore how we can split one big source file into multiple smaller source files. Now, this has multiple reasons why I want to do this. The first reason is, of course, readability. As you can see, this file is already quite big, and still 200 lines, it's totally maintainable, but especially when you're on big projects, as bigger the files are getting, the more harder it gets to navigate around them. Of course, there are tools in modern IDEs, like for example, Visual Studio supports the thing if you kind of like seen if the functions over here. This is why on a good practice I always told you to kind of like write these the declarations here at the top, and then have the definition or the source code, the implementation at the bottom, which already gave us a nice overview. So even if we would have a very big source file, you can see that we have all files on the top, and if we right click them, we can always like say peek definition, and it opens a little peek window where we can scroll and edit the code, or we can say right click go to definition, and it directly jumps us down there. So basically Visual Studio does supply a few functions and utilities that help us also navigate big source files. However, there is sometimes the point where you want to split them, because it doesn't make sense to have it all in one big source file. Not that big source files are particularly bad, but source files should be as short as possible, but not too short. As long as needed, but not too short. And today we're going to get to the concept. Even through like on this project, it would still be fine to have it in one source file. Even through I would always split it. Now this is like one idea, that you basically don't want to have two big source files itself. The other thing that we want to do is we want to might split logically our project. So currently the main is in the same file than all of our functions that are related to INI parsing. Now when the INI parsing gets complicated, writing this all in the same file than the main is not a good idea. So this is the other point of that, separating things that are not the same. So the main is kind of like our application, and the parse INI is a separate point of our application that does parsing an INI file, because you're probably never gonna have just INI parsing in an application, because INI parsing is used to, as you can see here, to customize something. So for example, supply information for the owner. The owner would be very certainly stored in a struct somewhere and then used to print it on the screen, for example. So we would kind of like in our main print, hey, the owner of this system is John Doe of the organization ACME Widgets Inc. So kind of like the INI is just a configuration for our application. So it makes sense to split it out. It makes sense to move all that INI stuff to a dedicated source file, where you basically just have all that INI stuff, and then you have one file just for your main, and then if you might do some processing with the database, which is defined down here, you would have one file that interacts with the database and stuff like that. So you try to kind of like split this up logically. You can use the full structure that Windows gives you. You can see if I would right click the INI parser, I can go on the add folder, on the add entry, I can add a folder, like I could do a folder util, I can add files to that folder, move files around, which I'm not going to do yet, create subfolders. So really what you have is you have like a whole idea of a Windows file system, or in general a file system where you can organize your code in source files how you like them. And the idea is that you're gonna always want to use it. You always want to make sure that you separate your code, structure it logically in folders and files, so that your application becomes readable. And it makes sense that all the INI parsing is in one file. It makes sense that maybe all the interaction of the database is in one file. If you have a web server, all that web server stuff is in one directory with multiple files in there. And the idea is basically to split everything nicely so that you can easily work with that. That's the whole idea. Now, another idea why you want to separate stuff into multiple files is reusability. Because INI parsing is something that's not only related to just our application to print the owner and connect to a database, right? An INI file could be used for any application you like, and what you don't want to do is you don't want to rewrite that INI parsing every time you create a new project. What you want to do is you want to write a so-called library. Not going to do this today, but that's the first step that we need to do. You always want to create like a library, which is just a collection of source files that are pre-compiled and already stored somewhere that you can then reuse in as many projects as you like. So the idea is basically a step ahead. After you have separated your source into these logical points, you can then basically factor out all that code that might be usable even further than this current application. And then you can write a library on top of that and work with it. We're not going to get that far, but however, we're going to already bring this into a separate source file, and if you don't create a library, you just need to copy the source file around, which is kind of bad, because if you change it in one place, the other place is not going to change. This is why you write a library, so that you have a unique source file for the INI parser, which is then compiled, and then every other application can reference that library and bring it in when it's getting compiled, and then you can reuse it. And when we are finished with all that INI parsing stuff, I'm gonna get to that. So when we are done with INI parsing and we have our INI parsing ready, we're going to transform it into a library, and then we're going to use it in another project. And you can see how easily it is to integrate these and have nice things. But the first step that we need to do there is we need to separate these out from the main in this case. So the purpose of this video today is separating the main and these three functions out. Now, before we're going to get started, I want to quickly give you a refresher on how the compiler works. This is quite a few videos ago that we talked about this, and I want to basically now give you a refresher. So what the compiler basically does, especially in the Visual Studio environment, it basically browses your whole project. So when you are hitting compile, the compiler will basically take a look at each file that is inside your INI parser project, or memory util, or however your project is called. Basically what it's going to do, it's going to search the whole project for any C files. And as soon as it finds a C file, it's compiling that C file. Compiling the C file is done in 2 steps. It's pre-processed and compiled. Now, how does that work? Pre-processing resolves all these hashtag symbols, so hashtag include and all things like that. That's all handled by the preprocessor. In this case, the hashtag includes basically provide the declaration for these functions that are not written by ourselves. So these are the declarations for our functions, for our INI parsing, and inside of these headers, there are the declarations for the printf, for example, or the string copy function, or the, what do we have as well, string cat function, printf, really no matter what it is, memcopy, whatever you need. So all of these declarations are inside these system headers, and with the hashtag include, we basically copy pasting them inside of that file so that we have all the informations how these functions can be used in there in our own C file. Of course, it's not copied physically, it's copied like virtually or in memory. This file is loaded into memory, and then basically the preprocessor does the copy and pasting in memory, and Then the compiler kicks in, reads the file from top to bottom. It says, aha, this is how parse_ini looks. Aha, this is how append buffer looks. Aha, this is how stripe buffer looks. All right, I find the function main. Okay, this is a const char. It is split into multiple lines. I don't like that. I'm going to match this all together in one line and write this somewhere in the executable. All right, there is a printf call. Do I know that printf? Yes, it was written somewhere up here that I've copied from that header. All right, printf is used like that. Okay, so I want to call printf like that. Then we have another printf. Okay, parse_ini. Do I know parse_ini? Yes, it's defined somewhere else. We already have an implementation. Yeah, no, I don't have one, but I don't care. I just assume that it's going to be there and it's going to look like that. And it's going to continue on and take a look at all of the other functions and mesh them all together, create binary code out of them, and spills them out as an object file. Now, after this happens with all of your C files, like the ini parse.c, currently our only C file, so we only get one object file, but if we have multiple C files, we get multiple object files, and after the compiler spilled out all multiple object files, the linker kicks in, takes all object files, loads them all into one big memory image, and then it tries to cross-reference. It tries to find parse_ini. It sees, all right, here was a parse_ini call. I have a parse_ini implementation in the ini parser.c, so I can link them together. All right, I found the main function, so I know what to write at the entry point of my application, and it basically takes all these information together, all the binary data together, and shoves that all into an exe file that then can be run on the system. Right? This is how the compiler worked. And now we basically need to find a way how to abuse the linker's functionality and the compiler's functionality to allow us to split our source into multiple files. Now, there are two steps ahead for that. So first of all, if we're going to separate the main from our parse_ini and append buffer and stripe buffer function, basically what happens is that inside main we are calling a function that is unknown. So if we would basically factor all of that code, starting with line 30, if we would factor this all out into its own dedicated C file, then what would happen is basically that parse_ini would be compiled. It would be compiled because the compiler has been told that there is a function that looks like that. It has been declared here, so the compiler knows how it looks like, but it doesn't find an implementation, and it doesn't care. It just splits out a call to that unknown function into that object file. So kind of like what we need to use is the linker. So basically what the linker is doing is it's cross-referencing different object files. So basically if we would put all implementations down here in its own dedicated C file, then it would be good, because if it's in its own dedicated C file and the C file is compiled, both of them are compiled, the linker can reference them together. So that's good. So what we can do already by assuming that is we can create a new item here. We can create a CPP file, call it, no, first of all I want to rename my current file. Gonna press F2. Rename this to main.c, because now I just want to have the main function in here, and that's very common that you're always going to call the one and only C file that contains your main, that you're gonna call this file main.c. I have not done this yet because we were not really requiring that, because we had all of the code in here, and as soon as you have multiple files, it's getting more relevant. If you just have one file, it's good and okay to just call it like the project, because then everything is in one single contained file. However, if you have multiple files, I would recommend you to have one file called main.c and the other files called whatever else.c. So now let's create the whatever else.c by right-clicking here, by right-clicking and crashing Visual Studio. Now we want to right-click it, hit add again, new item, and we're going to create a new CPP file. Now we're going to call it ini parser, not CPP, just .c, press enter, and we have our ini parser.c. Now I can go in here, go to that line, mark everything that we have here, and we want to Control X. That, save that, go to our ini parser.c, shove all that code in here, and we are done. And assuming that everything works, we should be able to compile it, and it should work. So let's right-click it and say build. Now, as you can see, build doesn't succeed. Why does the build not succeed? Well, the problem that we have here is that we are using these in32t things, and these things are not included here. So as I told you, the compiler is gonna take a look at each C file individually. So basically what we need is we need the includes in every C file where we need it. So It's not sufficient to just have them here, because if we just have them here, the includes, well, they are just valid for the main.c file, because the main.c file is compiled independently to the ini parser.c. So we need the includes here in the other C file as well, and if I add them here, save them, and build them again, by the way, you can do this by Ctrl-Shift-B for build. And now if I run this, it again fails. And the problem is that the append buffer function basically has not been forward declared. As I told you, to basically tell C how the functions look, you basically need to put the definition. You basically need to put the declaration at the top so that the compiler knows how they look. So basically what we had here, we want to move to there as well. Actually, we don't want to move it because we still need the declaration here as well, because we want to know how this looks in the main.c file, because we might use these functions. And we also need to know them in the ini parser.c so that we compile both of them. So if I now would hit build, you can see, all right, build, one succeeded. And if I would run it, you're going to get the same output that we had previously, which is exactly what we want, and boom, it works. Now, as you can see, very easily, we have splitted our code into two source files. Now, before we get started and talk about the problems, I want to do a quick cleanup, because we are just using printf in our main, and we are not using stdint, stdlib, or string.h, so I quickly want to remove them here, so that we are clean with the includes. As you can see, I can change this like that, and it still compiles like a charm. Now, what is the problem with that code? I told you that I really hate writing code twice. So what would happen if I change my ini parser.c? For example, I add a new function parse ini from file to parse it from a file. If I would do this like that, problem, we would need to copy that, for example. It's not bad to copy this. Let's maybe call this file path now. Parse ini from file. And I would add this function here. Now, the big problem is, if I add this function here, is that I also need to add it in my main.c file, because in my main.c file, I am using the code from the ini parser.c. So I need to paste this in here as well, so that I know that it's available here as well. And now imagine the ini parser is not only used in main.c. Imagine the ini parser is used in the my user config.c, my server config.c, my access config.c, my client connection config.c, my user logout, login, bloop, blub, blub, nobody cares.c, my other mad file.c, and I could continue on throwing words at you with the ending C. So as you can see, it's a problem. Every time we want to use these ini functions, we always need to write the declaration again. So you always need to copy and paste this. You need to have it everywhere where you use it. And you know me, that's not how I want to do things. I want to do things clean. I don't want to write them multiple times. I just want to write them once. And this is where the concept of header files comes in. The concept of header files that we have already extensively used by hashtag including something.h, which .h is a header file, is basically that the header file just contains all these declarations. So everything that we have written here and here, so the thing that we have duplicated, the declarations, all these declarations are going to be moved to a header file. And the header file is just there to hold declarations and be there as a copy-paste template for providing declarations for your functions. Now, how can we create a header file? Very simple. We right-click our ini parser. Going to say add, new item. You can see already just suggests that header file.h. Give it a name, call it ini parser.h. Why do I call it ini parser? Well, because it is accompanying the ini parser.c. So the ini parser.c contains the definitions, the implementation of our functions. So we want to create the same with the same file name, but with .h for the declarations, for the function signatures, how the functions look like. So kind of like our copy and paste template. Now, how I'm going to do this? Well, I'm going to cut them all out of the ini parser.c. .c, and I'm gonna move it inside the INI parser.h. Now you can see that Visual Studio by default already put us some code in the INI parser.h. I'm not gonna delete this, I'm gonna talk about this in a second, but for now I'm just gonna paste this one in here and keep it there. Now I'm actually gonna get rid of the parse INI from file, we don't need this yet, probably in the next video. So I'm just going to do this like that. Okay, so I basically have all of my declarations in here that I want to use in my INI parser implementation. Now inside the INI parser.c, I of course need to now know how the declarations look like. And how I'm going to do this? Well, basically what I'm going to do is I'm going to add an include here, so hashtag include. Now inside of normal quotation marks, I'm just going to write INI parser.h, and you can already see, like, if you press Control Space here, this always brings up the autocomplete in Visual Studio. You can see it's already suggesting us that I should include INI parser.h. So I'm gonna do this here. Right. Now I'm gonna do one more thing, because what's commonly done is that all of these libraries that are basically used inside the INI parser, they are always also included in the header file. Why are we always including them in the header file? Well, because most of the time, like stdint for example, if we would have an stdint as a parameter and I would write this in here, so in32tx, can see it kind of like detects that. However, if I would try to compile it, this is not known. This is now only known because basically what I'm doing is I'm including INI parsing, INI parser after the other includes. So in our case, the only time where we use our INI parser.h, this has been already included. However, if I would move this to the top of the source file, which is very commonly done, if I would move this here, you can see it's still kind of like trying to fool us into that it already works. But if I try to compile this, you can see that it throws us an error here. Visual Studio kind of like tells us that it is used, and it does know that. However, it does not. I think if I might reopen it, it might also reflect that. No, it doesn't reflect that, because this is how Visual Studio and the C and C++ languages try to trick you. This is always something, if you don't follow like the good principles there, you're gonna always have issues like that. Like, oh, it looks good, but if I compile it, it will fail. Right? This is an issue. It doesn't know that. Why doesn't it know that? Well, because the include is in the implementation, but we already need these headers in the header. So we already need to know what stdint is in the header to allow this and use it as a proper parameter. And this is why we basically move all of these library includes at the top of an header. Now you can see it's kind of like detecting that because I removed it, but you can see it's not really working properly. So you should really try to follow the things that I tell you here. So the idea is basically that you have all of these library includes. You should always have them in the header, at the top of the header, after the pragma once, to what we get in a second. Pragma once is going to be always at the first line of every header that you're going to have, no matter if you're in C or in C++. On C, there's also a different way, an older way to do it. However, every modern platform does support the pragma once, which is a bit more a bit better to use. But now, what does pragma once actually do? So, well, it's always there at the top of our source files, but what is it doing? Well, pragma once is a so-called include guard. What does include guard means? Well, it guards includes. Well, what do you need to guard when using includes? Well, in our case, include guards are not doing a thing. If I would remove the pragma once, we would be totally fine and everything would be good. However, there are certain scenarios where you're gonna get issues if you don't have the include guards. This is why we always put them at the first line of a file. So what would be a problem if we would not have include guards? Well, imagine you are having 3 header files and 4 source files. One is the main.c, the main source file, and the 3 other ones are always accompanied to the according headers. So we basically have 3 headers and 3 source files with some utilities in there. The one is called A.h and A.c, and the other one is called B.h and B.c. And both of them require certain utility functions that are stored in utility.h and utility.c. So we have kind of like 3 files, A, B, and utility. Now inside of A.h, we want to use the utility functions so that we can use them in the implementation of A. So what we do in the A.h file is we're going to include utility.h. On the file B.h, we are doing the same thing, because B, even though it does a whole different thing than A, but it still requires the utilities from the utility.h. file. So what we do is inside of a.h we include utility, and inside of b.h we also include utility. Now in our main.c source file we want to use both functionalities out of a and b. So what we do is we're going to include a and we're going to include b. Now if the preprocessor kicks in and tries to compile or preprocess the main.c source file before we're compiling it, it first stumbles upon the include a. When it tries to include a, it needs to rerun recursively on the new preprocessor directives loaded by copy and pasting the header h into our main.c source file. So what it finds is it finds an include to utility.h. So what we basically end up with in our main source file is including utility and a. Now we are getting to the include b. If we are including b, the same thing happens then with include a. So it also, the include b also resolves to kind of like include util and include b. Now if we would take both of them in one shot, you basically have include utility, include a, include utility, include b. And as you can see, we have 2 times include utility. Now you would think, well, it's not an issue because in utility.h we are just basically declaring how functions look like in a header. It wouldn't be an issue if we do this twice. And in general, this might be okay. However, especially on C++, but also in C, there are certain things that you can write in a header that are not fine being called twice. So there are certain expressions that you can write in a header that are going to fail if you are using it twice. So if utility.h is included twice, there are things that could fail the compiler. So the compiler then says, oh, it was already defined, so I cannot redefine it. And you would run into an issue. And this is why there is the include guard. So basically what the include guard does by specifying this pragma once, we are basically telling it pragma is just a certain keyword for the preprocessor to basically invoke a sub-application. In this case, it's kind of like invoking the sub-application pragma with the once keyword, and this once keyword tells basically this only is allowed to be included once. So basically what the preprocessor does every time you include this header file is it checks if it has been already included. So in our case, we would include a would include util would check, all right, am I already included? Preprocessor checks it, sees, okay, I do not know util yet, so util is included, and we end up with hashtag include a. Now we are getting to include b, which would also try to include util, but now the preprocessor again checks, do I have already included util? It sees, all right, I already included util at the a.h file, so it says, okay, screw it, I'm not gonna include it here, and you're just gonna end up with include b. So what we then basically got is include util, include a, include b, and we just have one version of our util header. Now, again, this is just something that you need to always remember, always have this at the top of a header file. It's important, especially in C++, there are many scenarios where this can fail and lead to very confusing error messages that you might not be even able to interpret. So you want to always make sure that you have a header, and inside of the header you're going to first include everything that you need, then you're going to declare your functions, and you are done in the header. In the source file, you're gonna, first thing, include the header, and then you're gonna add all the implementations of that functions that you're gonna use. And then, jumping back to our main.c, when you wanna use these functions, you wanna always make sure that you include it. So I wanna include here ini parser.h. So what I like to do if I use an own header, I always like to put my own headers at the top. This is also common that you always have your own headers at the top, followed by a new line, and then followed by library headers. Because stdio is, as you can see, also used by the ini parser. The ini parser also used as a stdio. And there's actually a way to customize how stdio gets loaded. So there is a way you can basically specify how you want to use stdio. And what you want to basically make sure is that your own header gets the chance to actually load the header how it likes to load it. So it's always good practice to have first your stuff and at the end the system libraries. It's just how you do it. One thing that you might have noticed is that we were using these normal quotation marks while the standard library had these brackets, the pointy brackets, how I like to call them. Basically the idea at the normal quotation marks are, hey, in the current directory, look for ini parser.h. While these pointy brackets basically mean, hey, somewhere find me stdio.h. And this somewhere is actually not like an anywhere. The somewhere actually follows a certain order where it's basically trying to find these directories, finding these headers. And basically inside of these path, it's a list of directories where the headers are allowed to be found, and basically in this list is the path to the Microsoft library. So if I click on this, you should see, or at least if I right click and say go to document, you can actually see that I can open this up. I don't see the path here, that's a bit of a pity. If I hover over that, I see this. You can see that, for example, this stdio.h header is in, come on, show it to me. See, program files, Windows kits, 10 include, version number, ucrt, stdio.h. So basically this directory is somewhere stored inside of our project. It's basically pointing to that directory, and by having these pointy brackets, you basically tell the preprocessor to search in the default path, while if you are having the quotation mark, you kind of like tell the preprocessor, hey, in the current directory, find me the ini parser. And that's basically how you do it. So you include it here, and down here you have the libraries that you need, and then you are done. You can hit compile and it should work. Currently it does not work because I have added the parameter in here that we of course don't need, but as you can see, everything else still works. But if I would now again remove this parameter here and hit build again, you can see one build succeeded, nothing failed. And if I would now start this, pressing F5, you can see that we are still getting the same output as previously. Now, this is quite nice now. As you can see, we have it now nicely structured. We have our main.c, which is our main entry point. You can see that the main entry point uses the ini parser. The ini parser itself, the header, is a very, very small and simple file that's basically telling us, all right, these are the functions that the parse ini or the ini parser supports. These functions are looking like that. They are declared here, and then you have the own separated source file where basically all the implementation of that functions are hidden. And that's very simple and a nice structure, and this is really where C and C++ shine, because they are like nicely separated. One thing that comes with that for free is knowledge protection. Knowledge, or also know-how protection, I think it's more called know-how protection. Know-how protection is especially important if you're talking about commercial software, and I know now that I'm gonna get full hate of open source community. However, there are software products that are closed source, so you are not allowed to view the source code. And C++ is very good at basically allowing these features. So basically, as a company, what you can do is you can write your software using .h and .c files, and what you're then going to do is you compile them to a library. I'm going to talk about this later. However, basically, when you compile something to a library, you're going to get a binary file out of that, a file that no longer contains the source code, but just a binary representation. And basically, what you then just need to do is you just need to distribute your headers and your binaries. And the nice thing is, if you're just needing to redistribute the headers, is that your customer can still see how the functions look. They still see, all right, there's a function called parse_ini that takes these parameters. But the customer does no longer see the implementation. The source file, it's hidden. It has been compiled to binary. Now, talking about this all library and code reuse stuff, you're going to have one problem with the code that we have written here. And the problem is the names. The problem with C that gets solved in C++ is that every function is in a global namespace. Namespace, it's a space for names. So all names that are allowed in your application for functions, all function names. And basically by using this append buffer function here, renders the whole name useless. So no other piece of code, no matter if it is a library, no matter if it is an operating system native function, no matter if it is a C standard library function, no matter if it is a function in your application, nobody else than that ini parser is now allowed to use the name append buffer. Append buffer, stripe buffer, parse ini. As soon as you use that name, it is reserved. Even if you're just using it in a C file, it is reserved because these names are not resolved by the compiler. The compiler is just going to output binary code with these names attached. And then the linker comes in and tries to match these names. Now, if you have used names multiple times, the linker will find two implementations of that same name find 2 implementations to one name, and the linker will tell it you, I don't know what to do, I have 2 implementations for the same function. And then it's gonna fail. And this is a big problem at C, especially on trivial functions like append buffer and stripe buffer. I'm gonna tell you, if you're searching the internet, you're gonna find a library that uses these names. Or you could find a library that might use these names. And you're gonna have an issue as soon as you try to pull this in. Pull this other code in with the same names and the whole application explodes. This is a big problem that we have here. And this problem was solved in C++ actually, and I'm going to show you how to solve it in C as well. So Parsing INI, it's not that big of a deal to have this name in here, because probably you're not going to have a different INI parser than the one that we have written. If you have written your own, then no point in pulling in another INI parser in here. So probably the parse INI function is fine to have it like that. But what we always try to do is to make our names unique. How can we make our names unique? Well, we do it by appending a prefix to them. And the prefix basically should be the name of our library, how we are writing this. In this case, it's not the library, but the piece of code that we're dealing with is therefore INI parsing. Now, how would we like to name our library? Well, I just name it INI. And basically what we're gonna do is we're gonna prefix each function with INI underscore. Basically what we wanna do is we wanna name our parse function INI underscore parse INI, INI underscore append buffer, INI underscore script buffer. So we always have like a prefix that identifies our library and then an underscore and our function name. And what we now have kind of like archived is that we can now give any name that we like to use for our own library. So our library now can have every name imaginable. It can collide with the standard library. It can collide with other libraries. It's not a big deal because everything is prefixed by our library name. Well, it can also happen that 2 people name their library the same, but that's not really a point, and that's also not solved in C++. If people name the library the same, that's always an issue, right? But normally this doesn't happen. If you name a library, you're probably going to take a look at if it's already existing, and if it's not existing, you use it. If it's existing, you need to find out a new name. So it shouldn't be a big deal. However, we're just going to call it INI. Probably there's already a library called INI, but for our case, it's good just to show the purpose of doing that. Now, what I'm going to do here quickly is I'm going to revert that change that I've just made, because this would now be a pain in the butt to solve it. Basically, what we now would need to do, we need to search for every occurrence and change it. We don't want to do it that way. We are cool. We can right-click this and say rename. If you say rename, it's basically bring up this dialog and associate this with the symbol. And what I can now basically do is I can now add the INI underscore prefix here, click on preview, and Visual Studio is going to try and find each occurrence, and you can actually see where this occurred. You can basically see that that name was used in INI parser.c, so it's basically going to change that name down here in our source file, in our INI parser.c file. It's going to change it to an INI parser. You can see it was also in our H file, so in our H file it's also going to change this to an INI parser, INI underscore parse INI, so we get the point. And you can see also in our main file, you can see it also detected that we used it there, and it also said that it's going to change this here. So now this tool is basically changing it 3 times. You can hit apply and boom, it has applied these changes to all of our 3 files, and we are good. And if I would compile this, you can see it still builds, and we haven't changed anything by hand. We just have written it once. Now we're going to do the same thing here for the other functions. So just hit that, enter. Initially see that this is used way oftener, but not in our C file, of course. Hit apply, done. No, right click here, rename, INI, strip buffer, also used quite a lot. Hit apply, done, compile it again. More builds, press F5, and still works the same. So you can like see the point in here. As you can see, if I would take a look at the source file here, everything has been replaced to my INI underscore. And you can see that everything is now in its own dedicated name, and we would never have some collision here. So now back to the C file. You can see INI underscore parse INI here, and we are actually good. Now, as you can see, again, have taken 40 minutes to completely rework a working project, and we haven't changed anything. But we have done one really important thing. We have learned the concept of splitting your implementations into multiple source files, which is really, really useful. When we are getting to C++, the the separation is going to get even more obvious, and it's going to get a bit more relaxed as well, and you're going to be fine there as well. Now, one thing that you also get from that is you get shorter compile times. The thing is that the Visual Studio IDE is smart. So if you are recompiling your project, so you're pressing F5, it's now also only gonna compile the code that you changed. So if you make changes in ini-parser.c and you hit recompile, it's not gonna recompile main.c because main.c had no changes. It's just gonna recompile ini-parser.c, which might change the functionality of main because, yeah, of course, the function that main was calling has been changed. However, main itself has not been changed. The source code and the binary code, the machine code for main is still the same. And the only thing that needs to be rerun is the linker. The linker just needs to link to the new implementation. But that's also something that you get from that. It's going to get this for free. And that's the end of the video today. I hope you understand why this is useful, and I hope you see the power also in structuring your projects there. So thank you for watching. Make sure to like and subscribe, and have a nice day. Until next time, bye.